Geoffrey Ventrella was born at the age of 0.
Was.
He's had some very interesting experiences and has worked with many of the three-dimensional world as well as the interactive game communities in developing various elements, developing environment, developing characters. And this latest venture that he has made is a very interesting combination of virtual and augmented reality. I will let him tell you the rest.
Artificial life meets augmented reality. This term A meets B might be a little cliche by now, but maybe it still has some currency. My MIT thesis was called Disney Meets Darwin. And as soon as I came up with that name of my thesis, somehow everything started to crystallize. This is a red dot. This is a red dot and a blue dot. It gets more complicated from here. Many years ago, I created a little plaything, and I was just exploring what happens if you have attractions and repulsions between things. When I was at the Media Lab, I did a project which I called Attractions and Repulsions, and there were three bodies, kind of the three-body problem attitude with creating artificial life interactions. You can change the values here to make them both attracted to each other, in which case they do the love dance, or they could be repelled by each other. I was working on this at the time for a woman who's a lesbian artist, and she said, why male, female? Why not two females, or why not something in between? And I thought, well, that's a cool idea. In fact, there's so many different kinds of attractions and repulsions that we and all organisms have with each other as part of the affordances of nature. And so recently, in fact, I created something which takes this idea to the extreme, I suppose you could say. If you have not just two colors, but many, many colors, where every colored particle has an attraction or a repulsion with every other particle, you have a squared exponential explosion of possible permutations. And the result is, and let me see if I can get this running in Chrome, but what's so wonderful about artificial life work is that you can be surprised. In fact, that's the idea, to be surprised. We're always looking for the unexpected, something that emerges from the primordial soup. The number of possible things that emerge from this is quite spectacular. This one I call acrobats because of the amazing acrobatic performances that these particle clusters make. This is partly influenced by the biologist Lynn Margulis, who is no longer with us, but she was a very important biologist who countered the somewhat outdated idea that Darwinian evolution is all about competition. She was championing the idea that it's more symbiosis and mutual compatibility is as important, if not more important, than competitiveness. And she and several other biologists were recognizing that mitochondria and other subcellular structures used to be their own selves, and then they joined other selves and became a unified self. And this combination of individuals to create composite individuals has continued on throughout biology, and perhaps our artificial intelligence will create the next level of selves where we are merely cells in that transcendence. In terms of levels of emergence, the idea of artificial life research is you take a certain primordial soup where you're simulating a particular level of nature and creating emergent phenomena on top of that. And I've always been interested in where you choose to create your simulation to create the emergence that comes beyond that. And gene pool, which I was just showing you, and I'll show you a bit more now, is something that I created many years ago. Some of you have already come across this simulation that I created in the 90s. It uses This is running in real time, and it uses a simple two-dimensional physics algorithm. And what it does is it creates swimming behaviors where I have not given any instructions as to what swimming means, simply starting with a primordial soup of random motions in these limbs. The lucky ones at the beginning who are able to find mates and have offspring are the ones who pass on their genes. This is inspired by something that Richard Dawkins requested many years ago. I think it was in the selfish gene or maybe the extended phenotype, saying, I want to see some people make artificial life simulations that show true Darwinian evolution, not just the lockstep genetic algorithm technique that had been used and is still being used. Obviously, it's very practical, but this way of running a genetic algorithm is much more true to nature. This simulation has become popular among biology teachers. I had a biology teacher in France who asked me to make a version with French, and I just got contacted by a Mexican biology teacher who wants to have a version with all Spanish in it. And I think the reason that these guys like the simulation is because it allows their students to experience kind of on a gut level what Darwinian evolution really means in the span of a half an hour or so. Of course, this thing can run all day or for several days or weeks, after which it basically tops out with a certain phenotype that wins out over all the others. But this is a very large space, and there is some interactivity involved here where one can manipulate things on many levels. And you can see the reason it's called gene pool is that there are pockets of genetic coherency that they emerge in different parts, and then they start to compete with each other. There's no cooperation in this simulation, by the way. So I encourage you to go check it out. There's a version on the, that runs on the iPad called Gene Pool Swimbots. So in thinking about AI and artificial life, one of my favorite topics is embodied intelligence. I forgot her name. She's a researcher in this field, and she says intelligence must have a body. And one of the problems that we have in design and in this era in which artificial intelligence is becoming infused into so much of our technology in our lives is that we expect intelligence to have a body. We expect some embodiment of sources of intelligence. And I think this is a subject that may come up more and more as we move through this adventure. The brain in a vat is a fallacy. Descartes was wrong. Intelligence requires a body, yes or no? I would say it does. You might think of mind as the verb and body as the noun. But what is the body of artificial intelligence? Artificial life came along right when good old-fashioned AI was starting to be seen as a problem because of the disembodied nature of so much of the research that was going on. And it is also very amenable to the maker attitude of building things and seeing what emerges. Brains evolved in bodies, bodies evolved in ecosystems. When I was working in Vancouver teaching a class at the Center for Digital Media, I did a research project which I called the gestural Turing test, which answers what I see as a bit of a problem in the Turing test, which is that it's all based on language and text, which is fine because I don't think Turing was trying to do something really huge. He was just posing a question, and that was a very, very important, pregnant question, and we've taken that a long way. But the question is, can you perceive a living system not by its words or language? Because after all, there's so much life out there that doesn't use our language, and we'd like to be able to perceive that. The dot pattern research where people look at dots and try to decide whether those dots are part of a pencil that you dropped on a table, and they say, it looks like a stick that's bouncing, or whether those dots are on a cat walking along the floor. I recognize that as a cat or some mammal. It's alive, it's not alive. These are things that the human brain is very good at detecting in the absence of the visual skinning, if you will, of the thing that's moving. So this research was done in a motion capture studio at Emily Carr University using a Vicom motion capture system. And we actually had real subject, and one of my students and I worked on the software to use imitation and various other algorithms to do that. And only 3 dots were used, the head and 2 hands. These are ideas that are very familiar to character animators. While I was in Vancouver, I wrote the book Virtual Body Language. And the book Virtual Body Language is really sort of the whole culmination of all the work that I was doing at there.com, which is a virtual world I co-founded, and also Second Life, where I worked for 2 years, developing various user-facing features for the Second Life platform, including avatar puppeteering and flexies. How many of you have been in Second Life and seen things that are flopping around? I invented those. Before I made flexies, everything was rigid and kind of boring. Now I'd like to show you where I've come since this whole era of virtual worlds that I was working in and doing research in. And that is a more recent project where I took a lot of the artificial life ideas and the avatar expression work that I was doing for there.com and applied it to animated characters. I call them self-animated characters. And I call them self-animated because there's no animator involved in these characters. Let me find a video that shows, this is called Peck Peck. This is one of the characters that I had developed, and this is Alan Sperling, who used to work at Pixar. He's a good friend of mine, lives right down the road up in Petaluma. And he was showing this to his students. What's that? And his students didn't realize that there was no animator who created this. That this was actually done with procedural animation and AI. And these characters have been extended to the iOS platform, where we have 7 apps on the Apple Store right now that you can purchase. Well, you don't have to purchase because they're all free. You can get these apps and breed these characters. So that instead of being created by animators, they're created by you breeding them. That's how they're created. And they grow in real time. Actually, I can throttle this down so it takes a day or a week or a month, however long, for these things to grow. These are perfect material for the next level of Tamagotchi. But in addition to that, in addition to the Tamagotchi effect, there's so much variety here. And I used to refer to Pokemon all the time as an influence. Of course, then they came out with Pokemon Go after we had already been developing an augmented reality version of this with geolocation. So let me move on to the next slide. And I hope we'll have time for questions, because that's where all the fun begins. Why augmented reality? I'm sure you guys have had many conversations about augmented reality and virtual reality and all other kinds of reality. A friend of mine calls this Facebox because Facebook bought Oculus. And he says that in a sort of a derogatory sense because it's sort of closing off from the world. Virtual reality, as powerful and useful as it is and will continue to be, is not the killer app that AR will be. Not yet. Because in virtual reality, you can't let the real world leak into your immersive experience. That ruins it. With augmented reality, it is all about the real world with augmentation. That's a much more human project. You can make the invisible visible, or rather combine the visible with the invisible. For instance, wouldn't it be cool to see photosynthesis happening before your eyes if you are a student learning about this kind of stuff? Photosynthesis being one of the most important moments in the evolution of Earth, where all of those organisms that hate oxygen were really pissed off at this new emergence, and they died off, and now we're here. Augmented reality with geolocation gives you a connection to place. When I was at MIT, we were thrilled about the internet, about how any place, anytime, anybody, space dissolves into non-existence and in a sense, time. And the internet sort of dissolves all of that fabric of space-time so that we can engage. But we lost something in the process. We lost the sense of place. We lost some of our connection with each other. So now new technologies are bringing that back, mobile being one of them. When we were developing a book for a Kickstarter campaign, which we received money for that to do this project, and we have some goodies here. I can hand out a few as a result of the Kickstarter campaign. We were trying out with little girls and boys, and I don't know if any of you used Vuforia with Unity or some of these technologies, but there's a thing called extended tracking, which is an augmented reality technology that allows the computer vision system to handle the loss of a visual marker and to use something else. So for instance, if you put your hand in front of a visual marker, a smart augmented reality computer vision system will take that hand and say, okay, now that's my background. It's sort of the little beginnings of the SLAM approach. But this little girl would put her hand in front of this character, and me and my teammates were saying, no, that's not how you're supposed to do it. Don't put anything in the way. And she didn't listen to us. She just kept carrying her character around. She had established an emotional connection with this character. And she really drove our thinking at that point to listen to what she was saying and not be so attached to the technology. Peck's perch, and what I can do is I can show you, maybe after the talk if there's time, I'm wearing the t-shirt with this augmented reality marker. We have two versions, one with flowers and the other with bird poop. And Peck sits on your shoulder. And she flies. So I'll show you a video of that here with some of my coworkers. We were rolling out videos during our Kickstarter campaign, and this was one of them. That's me holding the iPad, flicking Peck off of Natasha's shoulder. Peck flies back onto her shoulder. And it's basically an experiment in making animated characters that you can not only customize, but you can carry around on your shoulder. And this just scratches the surface of what's possible with these new kinds of animated characters. We ought also come up with ideas for if I have my t-shirt and you have your t-shirt and we stand together, my character and your character might do a little tango and we can have a new character as a result. So I think there's so many possibilities now with this. Emergent narrative. If you extend this beyond cartoon characters where artificial intelligence and artificial life are fused with geolocated with geolocation and all kinds of AI in the cloud, you can imagine putting on your new augmented reality glasses and seeing a couple of characters standing on the street talking, having a conversation. Well, these are virtual characters, and I'm imagining a kind of a game in the future where you can actually walk up to these characters and start talking to them, and they'll gather your language and add that to their emerging narrative, and you can become a part of the narrative. So when you add AI with embodiment, meaning a real place, a real time, real people that they've interacted with, you can have an exponential growth of AI behaviors that are meaningful. What makes all this possible? All the sensor fusion of these different technologies, which include the accelerometer in your cell phone, the gravity sensor, the compass, and of course computer vision and geolocation. All of these things are being fused to the point where we're no longer thinking of them as individual pieces. We just have it on our devices. And I just love the idea of the compass knowing where north is, and the accelerometer and the gravity sensor, which I take the vectors from this and I create an orientation, which is a unique orientation right here on Earth, different than any other orientation. That just blows my mind. I believe that augmented reality characters with embodied intelligence can help us become more connected to the environment and to ourselves. That's the takeaway. And I'm going to keep it short because I'm late, and so maybe there's time for a few questions.